Hey, what's up, guys? It's Nicola from Calcunic, and today we're going to talk about the quotient rule. Let's get right into it.
So the quotient rule is going to be really helpful when we're asked to find the derivative of the division of two functions. So let's say we have the derivative of two functions being divided, f of x over g of x. And so the quotient rule will tell us that this is equal to f prime, or just the derivative of f, times g of x, and then minus f of x times g prime x, or just the derivative of g, and that's going to be all over g of x and then g of x squared. And so in practice, it's going to look something like this. Let's say we're asked to find the derivative of this function. We have 3x minus 2, and we're going to have that all over x minus 5. Now we could go right into solving this. However, I think starting off it's a lot easier to write out the two separate functions in the numerator and denominator and find their derivatives separately to ease the calculations. So first, our numerator, we'll call it f of x. And in this case, the numerator, or f of x, is equal to 3x minus 2. And just to find this derivative, it's pretty easy. We have 3x, and the derivative of 3x is just 3, and minus 2 a constant, and the derivative of a constant is 0. So f prime x is just 3. In the denominator, we have g of x is equal to x minus 5. And this derivative is just the derivative of x, or in this case, or it's just 1. And so if we write this out, we get that this is equal to, in the numerator, f prime x times g of x, or 3 times x minus 5, and then minus f of x times g prime x, so f of x, 3x minus 2, times g prime x, 1. And this is all over g of x squared, or x minus 5 squared. Now, we have that this is going to be equal to 3 times x times 3 times minus 5. So we have 3x, and 3 times minus 5, that's minus 15. And we also have 3x minus 2 times 1. When we multiply anything by 1, that's just itself. So all we have is this negative sign here. So we have minus 3x and minus negative 2. So we get minus 3x and minus negative 2. That's two negatives, so that becomes a positive. We have plus 2, and the denominator is just going to stay the same. And our last step is going to be group-like terms. We see that we have 3x and minus 3x. They cancel out. And all we have that's left is minus 15 plus 2, so that's minus 13. And that's going to be all over x minus 5, and finally squared, giving us our final answer. So let's try another question. We're asked to find the derivative of x squared minus 3 all over x plus 6. So once again, we'll identify the two functions we're working with. So first we have f of x is equal to x squared minus 3. This derivative, using the power rule, we get that it's just equal to 2x. And the denominator, we'll call it g of x. And this derivative is pretty easy. It's just 1. And so when we work this out using the quotient rule, we'll get that we'll have f prime x times g of x in the numerator first. So that's 2x times x plus 6 minus g of x, or x, that's going to be minus f of x, or x squared minus 3 times 1. So we could just leave that out because it doesn't do anything. And that's all over g of x squared, or x plus 6 squared. And so now we do some reducing. We have 2x times x and 2x times 6. So that's equal to 2x squared plus 2x times 6. That's 12x. And then over here we have minus x squared and minus 3. So that gives us minus x squared, and two negatives, that's a positive, plus 3. Once again, all over the denominator, x plus 6 squared. And now we group some like terms. We have 2x squared and minus x squared, so that becomes just x squared plus 12x plus 3, and this is divided by x plus 6 squared, giving us our final answer. So let's move on to some examples using trigonometry. And so we're asked to find the derivative of cosine of x over x squared. In this case, we could write f of x to be equal to cosine x, and the derivative of cosine is just minus sine x. And now in the denominator, we have g of x is equal to x squared. And so the derivative of x squared using the power rule is equal to 2x. So now we could use this information to solve the question. In the numerator, we have f prime x times g of x. So that's going to be equal to negative sine x times x squared, and then minus f of x times g prime x, or cosine x times 2x. And the denominator is g of x squared, and x squared is just x to the power of 4. And so what I'm going to do here is factor out a term of minus x. So we bring out a term of minus x in front. And so in minus sine x over x squared, that reduces the x by 1, and the minus sign goes away. So we have sine of x times x, and then in cosine x, the minus sign goes away, and also one term of x. So we're left with plus 2 cosine x. Once again, the denominator, x to the power of 4. And now we could reduce a little bit. We have an x here, and so that reduces the power of 4 down to power of 3. And we'll just write the negative sign out in front. So we have minus x times sine x, just rearranging the order there, nothing changes, plus 2 cosine x all over x cubed in the denominator. So we're asked to find the derivative of sine of x over cosine x. And so in this case, the numerator, f of x, is equal to sine of x, and this derivative is known to be cosine x. So f prime x is equal to cosine x. And then we have g of x, the denominator, is equal to cosine x. And the derivative of cosine, as shown before, is minus sine of x. And so we could use this information now. And so in the numerator, we have f prime x times g of x. So that's cosine x times cosine x, or just cosine squared x, and minus, we have sine x times minus sine x, so that's going to be equal to minus sine squared x, and all over the denominator squared, so cosine squared x. And notice how in the numerator we have a double negative, so that becomes a positive, so we have cosine squared x plus sine squared x all over cosine squared x. And so we could stop here, but there's also an interesting property that we could use. We have in the numerator cosine squared x plus sine squared x, and this in trigonometry is known to be equal to just 1. And so we have that this is equal to 1 over cosine squared x. Another thing we can notice that is 1 over cosine x is equal to secant x. So therefore, 1 over cosine squared x is equal to secant squared x. Our final answer. Now, just one more cool thing I would want you to notice is that we have sine of x over cosine x, and sine of x over cosine x is literally just tangent of x. So secant squared x is also the derivative of tangent of x. And so in fact, using the quotient rule, we could prove what the derivative of tangent is, secant squared x. So let's try some examples now with e in the natural logarithm. We're asked to find the derivative of e to the x over 2x plus 5. And so in this case, we have our numerator, f of x is equal to e to the x. And this is a very easy derivative to remember. It literally just stays the same. We just have e to the x. And then we have our denominator, g of x. This is equal to 2x plus 5. And the derivative of g of x is equal to 2. And so now if we use the quotient rule, we get that this derivative is equal to f prime x times g of x. So we have e to the x times 2x plus 5. And this is minus, we have f of x times g prime x. So e to the x times 2, we got 2 to the e to the x. And that's all over the denominator squared. We have 2x plus 5 squared. What we could do here is actually factor out a term of e to the x. So we have e to the x, and on the inside we have 2x plus 5 minus 2, and that's going to be all over 2x plus 5 squared, and this finally is equal to e to the x times 2x plus 3 all over 2x plus 5 squared. So let's try one last question. We're asked to find the derivative of x squared over ln of x. And so in the numerator, we have f of x is equal to x squared. And using the power rule, we have that the derivative is 2x. And in the denominator, we have g of x is equal to ln of x, the natural logarithm, and the derivative of ln is equal to 1 over x. And so now using that and the quotient rule, in our numerator we'll have f prime x times g of x, so 2x times ln of x, and this is going to be minus f of x times g prime x, so we have x squared all over x, or x squared times 1 over x, and this is divided by ln squared of x. Now we could see that this is equal to 2x ln x, and x squared over x, well that's just x, all over ln squared of x. And finally we factor out a term of x to give our final answer 2 times ln of x minus 1, all over ln squared of x.
Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you made it this far, leave a thumbs up if you liked it, and subscribe if you loved it. That's all for me. Till next time.